7, we're just evaluating some limits, but for these, they're more complex limits that can't just be solved by direct substitution, like plugging in the actual value. We're going to need to use L'Hopital's rule. So, for letter A, we have the limit as x approaches 1 of x times x minus 1, or x over x minus 1, minus 1 over ln x. You can see here that if you try to plug in 1 for x, we get something that's undefined minus something else that's undefined. So we don't know what this is. We need a way of solving it. That would be L'Hopital's rule. But in order to do that, we need to get it to be one fraction first. So by doing a common denominator, that's how we're going to get that done. So what this is going to be is x ln x minus x minus 1 all over x minus 1 times ln x. So you can see here that this is x ln x minus x plus 1 all over x minus 1 times ln x. So in doing this, just by combining them, you're never going to change the fact that it was undefined. But now we're ready to do L'Hopital's rule. Because remember, L'Hopital's rule says that if you have the limit of something and it's undefined, the limit of the derivative of the top over the derivative of the bottom is the same as the original limit. So if we take the derivative of the top and the bottom, we should get the same thing, speaking of the limit. So the derivative of the top, x ln x, we have to do product rule. So that's going to be ln x plus ln x times 1 plus x times the derivative of ln x, which is 1 over x. The derivative of negative x is minus 1. Derivative of plus 1, 0. On the bottom, we need to do product rule between x minus 1 and ln x. So the derivative of x minus 1 is 1 times ln x plus the derivative of ln x is 1 over x times this. I'll just divide it like that. You can see here that x times 1 over x is just 1. And we have plus 1 minus 1, which cancel out even further. So this just becomes ln x over ln x. And I can make this even easier as well by splitting this into two fractions. This is going to be plus 1 minus 1 over x. So the first thing you want to do once you've done that is try your limit again. So we're trying for x to be 1. If x is 1, ln of 1 is 0, so the top is 0. We get 0 plus 1 minus 1, which is 0. So we still have indeterminate. We need to do L'Hopital's rule again. So if we do L'Hopital's rule again, we're going to get 1 over x, 1 over x, and when you do the derivative of 1 over x, you would get negative 1 over x squared, but because it's subtracted, we're getting plus 1 over x squared. This we can do a lot of simplification to. We can get a common denominator of everything by multiplying these by x over x. So what we get is x over x squared over x squared plus 1 over x squared. If everything in your fraction is divided by x squared, you don't need it, which means this is the same as x over x plus 1. So we actually got that the limit as x approaches 1 of x over x plus 1 is the same as that limit. So that's what L'Hopital's rule is telling us. This is indeterminate though, and this is definitely not, because now if we plug in x equals 1, we get 1 over 2. So we get that our limit, according to L'Hopital's rule of this function, is 1/2.